ladies and gentlemen, we are looking at notes 3.6, which are on connecting variation, slope, and first differences. So basically, essentially, this set of notes is going to bring everything together for us for this unit. So the first thing that I want you guys to notice is that we have the rule of 4 on our paper right here. And the rule of 4 says that a mathematical relation can be represented in 4 different ways. Well, what are those 4 different ways? It can be represented in words. And when it's represented in words, we say it's represented verbally, okay? Or written representation, okay? We can also have it represented in a chart. And this type of representation is called numerical representation. So we're representing it numerically because our chart is filled with numbers, okay? We can also represent our information in a graph. And if we do it that way, then we're representing it graphically. Okay? And lastly, the last way that we can represent our information is in an equation. And the way, when we do it that way, we're representing it algebraically. So what I'm going to do is I'm going to look at a bunch of different examples, 3 different examples, and we're going to have it represented in one of these 3 ways, and we're going to put it in the other, it's represented in one of these 4 ways, and we're going to put it in the other 3 ways, okay? Take a look at scenario number 1. In scenario number 1, it says that a cable car starts at a height of 700 feet, so that the word starts is important, 700 feet, and is descending. Remember, descending means goes down at a rate of 30 feet per minute. So here, this has all the stuff that we need in order for us to be successful with this problem. The first thing I want to do is I want to identify what are my 2 variables, what are my 2 things that are constantly changing. Well, the time is changing, but the time is the independent variable, so we're going to let time be x, okay? And then we also know that the height of my cable car is decreasing, but the height is based on the time. It depends on the time. So that's the dependent variable, so we're going to call it y, okay? And that's really going to be helpful for us when we do all of our each piece right here. We need to know the x and the y when we do our chart. We need to know the x and the y when we do our graph. And we need to know the x and the y when we write our equation, okay? So right here, we've got our x, remember, always goes on the left side, and our y always goes on the right side. But this right here is our x is our time. So we're going to put time here, and the time is measured in minutes. And then our y is our height, and our height here is measured in feet. So when no time has gone by, it says that the cable car starts at a height of 700 feet. Okay? And then if it's descending at a rate of 30 feet per minute, we know that after 1 minute, it will be down to 670 feet, because I just went down by 30. As this goes up by 1, as the time goes up by 1, the height will go down by 30 feet. That should make sense to you. Do you now see how things are starting to come together? Now we're talking about first differences. This is where our slope is starting to come in. It's all connected. As the height increases by 1, as the time increases by 1, our height decreases by 30. And it just keeps happening. Okay, so, and we can keep going with our chart, but this is enough for us to be able to get enough information to do our graph. So the next thing we're going to do is our graph. And we always put our independent variable on the x-axis, and our time is being measured in minutes. And then we put our dependent variable on the y-axis, so our height is our dependent, and it's being measured in feet, okay? And our time, we're going to go by 1, 0, 1, 2, 3, all the way up to 10, okay? And then our height, we know our maximum height is 700. So I'm thinking maybe I should go up by 100. So this will be 100, this will be 200, 300, 400, all the way up. So I'll put 600 here, 800 here, and then I'll put 1,000 at the top, okay? And we know that initially it starts at a height of 700. So I'm going to put a dot right at 700. I'm going to put a coordinate at 700. After 1 minute, it's gone down 30 feet. So after 1 minute, I know it's going to be 670. I know that after 2 minutes, it's going to be 640. So I'm just going to keep going with this pattern right here. And every 30 minutes, it keeps going down. So at 3 minutes, it's 610. At 4 minutes, subtract 30 again, you're at 580. At 5 minutes, it went down to 550. At 6 minutes, we should be at 520. At 7 minutes, we should be at 490. At 8 minutes, we should be at 460. 9 minutes should be at 430. And then 10 minutes, we should be at 400. Okay, now if you notice my graph isn't totally straight, and that's because my scale is pretty tight, and that's okay. You should have like just a general idea of what it's going to look like. So now that we have our general idea, we can go ahead and connect our dots, and this is what our graph is going to look like right here. Okay, so now that I've done that, I can go ahead and write out my equation. Well, I know for a fact that this is partial variation. And how do I know it's partial? Because there's a rate of change and there is an initial value. Okay, so since I know there's a rate of change and an initial value, I can use my equation for partial variation. So I can use y equals mx plus b, where we already identified that our y is going to stand for, sorry about that, our y is going to stand for our height and our x is going to stand for our time. Now our m, the question is, what's our m? What's our rate of change? Well, we know it's going down by 30 feet per minute, so it's negative 30, and we know that it starts at 700 feet. So based on that, I can say y equals negative 30x plus 700. That's my answer as an equation. Now that I've done that, I want to make sure my equation makes sense. So if y stands for the height, I'm saying the height is equal to negative 30, so it's going down by 30 for every x for every minute, but it starts at 700. Definitely makes sense, so I'm good to go for scenario number 1, okay? Take a look at it, scenario number 2, which this time we're given information in a table. So if I'm given my information right here in a table, first thing I need to identify is that x, or my time in hours, is going to be my independent variable, and then my cost in dollars is going to be my dependent variable, so it's going to be my y. So now that I've done that, I can go ahead and create my my graph. So right here I know this is going to be time in hours. And I know that this right here is going to be cost in dollars, okay? So my time in hours starts at 0, and it's just going up by 1. So I think going up by 1 is a good scale to have right here. And then my cost is starting at 40 and going up to 85. So I think maybe going up by 10s will be the best option. So I'll put 10 here, 20 here, 30, 40, 50, 60, 70, 80, 90, and 100. Well, now that I've done that, I can go ahead and just draw my graph. So I know that at time 0, after 0 hours, you have to pay $40. So I'm going to put a dot at, or a point at 0.40. Remember, this is my initial amount. After 1 hour, I have to pay $55. After 2 hours, I have to pay $70. After 3 hours, I have to pay $85, and that's the pattern that's happening right here. So that's what my graph is going to look like, okay? Now that I've done that, I need to write my equation. I'm doing the words at the end because this scenario is going to be based on my understanding of the other 3 ways to represent this information, okay? So in my equation, when I look at this right here, it still tells me that I have partial variation, again, because I have a straight line, so I have a constant rate of change, and I also have an initial value, okay? So I'm going to use y equals mx plus b again. But the question is, what's my m? Well, I have 2 ways I can figure out my m. One way I can figure out my m is by doing rise over run. So I can figure out how much did this rise by, how much did it run by? Well, it went from 40 to 55, so it went up by 15, and it went over by 1. So my delta y over my delta x, or my rise over my run, is going to be 15 over 1, which is 15. But let's confirm that it's really 15 over 1 using our first differences. So from 40 to 55, it went up by 15. From 0 to 1, it went up by 1, which is exactly what I want it to do. From 55 to 70 goes up by 15. From 1 to 2, it goes up by 1. From 70 to 85 goes up by 15. From 2 to 3, it goes up by 1. So it's 15 over 1, or just 15, okay? So I know that my m is no longer a mystery. It's my 15 right here. Now, as a rate of change, it's 15 what per what? It's $15 per hour. So that's important for me to know. Now, my initial value, where did I start at? I can find it two different ways: by looking at my graph, seeing that it starts at 40, or looking at my table and looking for when x is 0. And when x is 0, my starting amount is 40. So then I can say that my equation is y equals 15x plus 40. So that's my answer right here. So now let's see, what does y stand for? Y stands for cost. So the cost is equal to $15 for every x, and x is the time in hours. So the cost is equal to $15 per hour plus an initial $40, okay? So now in words, I can create any scenario that I want related to something with an initial cost of $40 and something that would go up $15 per hour. So for example, I could say that I want to rent a conference room, okay? So, sorry about that, we're gonna go right here. So to rent my conference room, I'm gonna say Bob is renting a conference room. It costs $40 initially, so there's an initial fee of $40 and an extra, hopefully you'll know that the answer is $15 per hour, okay? And that's how I do scenario 2. That's how all of my stuff is related in my rule of 4, okay? All right, last scenario that I want to look at with you guys is scenario number 3. This time you're given information in a graph, and we need to identify, first of all, what are our x and y variables? Well, the graph is easy because my x is always going to be the horizontal axis, and it's even labeled for you here, so I know that the distance is x, and that the cost right here is going to be the y. Now be careful, when we're done, we have to make sure that we use C for cost, because that's how it's labeled in our graph. But it's not a big deal, it's the same idea. So in order to be able to figure this out, let's do our table first. Because our table is nice and easy, we can go ahead and fill in some information just from our graph. Going graph to table, table to graph is probably the easiest one to do. So in order to be able to do this, I need to figure out, well, what's going to go in my x side of my graph? Well, this is going to be the distance, because that's how it's labeled. So this is distance in miles. Okay, what's going to go on the y part of my graph? It's going to be the cost, and the cost is going to be in dollars. So I know that when I've gone 0 miles, I have to pay $100. Okay, I have another point right here, and that point is telling me that when I go 20 miles, I have to pay $200. Okay, when I go 40 miles, I have to pay $300. And sorry that this is in miles and not kilometers. When I go 60 miles, I have to pay $400. Okay, so the going, again, between table and graph is so much easier than any of the other ones that we've done. So now I have to figure out what my equation is going to be. Well, again, I know this is partial because we have a constant rate of change and because we have an initial amount. Therefore, we need to use y equals mx plus b. So I need to figure out what my m is. Again, there are two different ways that I can find the m. The first way is just by doing rise over run. Now be careful, don't tell me it went up by 1 and over by 2, because each box does not represent 1. It went from 100 to 200, so it went up by 100, and it went over by 20, because it went from 0 to 20. So this means that this is going to be 5, okay? I can also look at it right here. It's plus 100 for all of these guys. My first differences are plus 100 on my y's and plus 20 on my x's. So I can still do the same thing and do 100 over 20, which is 5. But remember, we need to know this is 5 what? Our constant rate of change is $5 per mile. Okay, so we're going to say it's $5 per mile right here. So we're going to say that our M is 5, but what's our B? What's our initial amount? Well, I can find it from my chart right here, or I can just find it from my graph. When x is 0, y is 100. Right here, it starts on the y-axis at 100, so my B value is 100. So therefore, I can say y equals 5x plus 100. But let's make sure that this makes sense. Remember, y is our cost. Oh, and by the way, I apologize. We need to say, instead of y, we need to say c, because that's how it's labeled right here. So the cost is equal to $5 for every x, for every mile, plus an additional $100. And that should be accurate. Okay, so in words, we know specifically what this scenario is about. In this example, we could had some room to be a little bit more, we've got a lot of different options for scenarios, but here we know specifically that it's talking about total charges for a car rental. So we're going to say in our scenario right here in words, it costs an initial fee of $100 to rent a car, plus an additional $5 per mile. And that's how everything is all connected. All right, I will see you next time I see you in class. Have a great day.